Here we are in section 5.3, and we've got the following 12 through 17. Factor the following using the ax squared plus bx equals c. Note that it is a equals 1. So that means right here, notice there's a 1 in front of that x squared. So that's what we're going to be doing. So here we're going to be breaking it up into two things where we have an x and an x. And then we're going to be looking to see what times us to negative 84 and then adds to negative 5. So let's go ahead and write out all the things that we can think of that times to negative 84. 1 and 84, 2 and 42, 3. Will 3 go into that? I think it will. 3 goes into that. Looks like 28 times. And 4 goes into that 21. And 5 and 6 goes into that 14. And 7 and 7 will go into it 12 times, 8, 9, 10, 11, 12. There we go. So if we look at these, one of these has to be negative, one of them positive. So if we put negatives down here, we can kind of see which set is going to add to 5. This is adding to negative 83, negative 40, negative 25, and there we have it. The 7 and the negative 12 add to the negative 5. So it's x plus 7, x minus 12. Let's try this next one. So we're going to have x and x, so that they times together to give us the x squared. And so we have a negative 6 out here. We could have a 1 and a 6, or a 2 and a 3. And that's all we've got. One of them has to be negative. Again, let's put it over here just to see if we can see what they add up to. That adds up to a negative 5. Nope. That one right up there adds up to a negative 1. So that's the one that works. Plus 2 minus 3. And it would not have mattered if we had written this x minus 3x plus 2. That's the commutative law of multiplication, so we're fine there. Okay, let's try the next one. We have x and x. We're trying to multiply to a negative 35. That's going to be a 1 and a 35, or a 5 and a 7. That's all we got. To add up to a negative 2, it looks like we need a negative 7 and a positive 5. And that multiplies to negative 35 and adds to negative 2. So let's put that in. X plus 5, x minus 7. And there we go. Now we have x, x. We have a positive 54 out here. Positive 54. That'd be a 1 and a 54, a 2 and a 27. 3 and what goes 18, I think. 4, nope, 4 doesn't work. 6, yeah, 6 and a 9. 7, 8, nope, that's all of them. Now, if we look at this, this is a positive 54, which means these two numbers have to be the exact same number. I mean, the same sign, both positive, both negative, etc. So if we look, these two will add to 55, these two will add to 29, those two will add to 21, and those two add to 15. So it's going to be these two, but these two add to a positive 15. We need a negative here. Negative 6 and a negative 9. Those will times to a positive 54 because the negative times a negative, but they will add to a negative 15. So that's a negative 6 and a negative 9. Good deal. 16. We have... Let's see, we've got the two things here we need, an x and an x. We've got 81 out here. What multiplies up to positive 81? 1 and 81, 2, no, 3 and 27, 4, 5, 6, 7, 8, 9, and 9. Oh, and look at that. There's our baby right there. We've got to have a negative and a negative. Don't mistake about that. You have to have negative and negative to add to a negative and times to a positive 81. So that's x minus 9, x minus 9. Oh, hey, look. Those are the same thing. We could write that if we wanted to. Not necessary, but we could write it like that. That's pretty snappy. And the last one, number 17. We have x and an x. And we're trying to times to a negative 33. Important that we keep that negative sign there. This could be a 1 and a 33. Or the more common one to get to 33 is 3 times 11. And I think that's all we got there. One of these has to be negative, one of them positive. And we're trying to get to a negative 8. So that looks like a positive 3 and a negative 11. And just for variety, I'm going to write it like this. And there we go. Good.